Hello, in this video, I will explain to you on how to find I0 in this circuit. So I0 is the current that pass through this 1 ohm resistor here. That is our goal. So our goal is to find out I0 or I0. And we need to use nodal analysis. Okay, let's do it step by step. The first thing that we need to do is to label all the nodes in the circuit. So the first step is label all the nodes in the circuit. However, we also need to find some more information during the labeling of the circuit. Okay, let's label our first node here, which is the bottommost node, and we need to make it our reference node. So this is our reference node, and some other books call it the ground. And what does that mean? That means that the voltage in this node here will be 0. So we will have our P is equal to 0. Okay, but what is the consequences of having this node here assumed to be 0? We have this node here, and we have that 180 volt voltage source, right? And remember, the definition of the voltage source is the difference between the positive terminal and the negative terminal. The positive terminal is connected to here, and the negative terminal is connected to this one. So to make the difference 180, this node has to be 180 volt, right? Because if we subtract this and this, we will have 180 minus 0, and that will be 180, right? And that is the first consequences of setting this reference node as the ground. However, we also have this 90 volt voltage source. So another consequences is that we know this node here. So the difference has to be 90, but we know that the negative terminal is connected to 180 volt. To make the difference 90 volt, we add 90 to 180. So here, I will have 180 plus 90. So we will have 270 volt in this node here. And I think that's good. But we have another nodes, right? So this node here, that is unknown. And this node here, that is also unknown. This node here, let's name this as node A. So I will have the voltage here will be VA. And let's name this node here as node B. So the voltage here will be VB. Good. And I think we have labeled all the nodes in the circuit. And also we infer some precious information. So we will have to do second step here, which is assume the directions of the current. Assume the directions of the current. The currents. Okay, let's see here. We have given IO, so I just follow this. So let's just follow that IO in this branch, and for the other we can just assume arbitrarily. I will assume this goes down, and this also goes down, and this maybe goes down. And for the branch with the current source, I just follow the arrow here. So this will goes up here in this branch. Okay, I think we have done assuming the direction of the currents. We don't need to assume in the voltage source because we already know the node voltage here, right? So we will have to do the step number 3, which is do KCL at all unknown nodes. Okay, what are our unknown nodes? We have not known VA yet, and also we have not known VB yet. So we need to do KCL at VA and VB. Let's exactly do that. The first KCL that we need to do is at VA. KCL at VA, and KCL said that the sum of the current that goes in will equal to the sum of the current that goes out, right? Okay, let's see here. The only current that goes into VA is this one, and the current comes from this node here, which is 270. And the current goes to VA, so I'll have minus VA. And that is voltage. We need current, we need to divide it by the resistance between them. So I will have 2 ohm here. Good. And all the other currents are going out, so we will have this equal sign, and we have this current here. The current comes from VA, and the current goes to VB, so I have VA minus VB. Okay, divided by the resistance between them, I will have 1. Good. And then I will have this current here, and that current comes from VA, so I will have VA, and then minus the current goes to the reference node, the voltage there will be 0, so I have 0 divided by the resistance between them, so I will have 5. Good. And I think we can multiply both sides here by 10 to get rid of all of the denominator, right? So I have 10. 2 and 10 will cancel into 5. 270 multiplied by 5, that will be 1350, right? And I will have minus 5 VA, and this will equal to, I think I will have 10 VA, and then minus 10 VB. Okay, 5 and 10 will cancel into 2, so I will have plus 2 VA. Good. Now 10 plus 2 is 12, 12 plus 5, that will be 17. I will have 17 VA, and then minus 10 VB. Okay, and that will equal to 1350. Good. Now let's set this here as equation number 1. Okay, and now we need to do another KCL, but this time at VB here. Let's do that. So the second KCL that we need to do is in the node P. KCL at VB. Again, KCL said that the sum of the current that goes in will equal to the sum of the current that goes out, right? Okay, let's start from this current here. So we will have VA, where the current comes from, and then minus VB, where the current goes to, and then divided by the resistance between them, I will have 1. Then we will have plus this current here, I will have 180, then minus VB. 180 is where the current came from, and VB is where the current goes to, divided by the resistance between them, so I will have 4. Okay, and this current also goes in, so I will have plus 45. And all of that will equal to 0. Good. And I think we need to multiply both sides here by 4. Okay, on the left hand side, we will have 4 VA. 4 VA minus 4 VB. Okay, 4 and 4 will cancel each other, so I will have plus 180 minus VB. And then we will have 45 multiplied by 4, that will be 180, right? And all of that will equal to 0. Let's do some simple math here. I still have 4 VA. Okay, and then I will have minus 5 VB. But then let's move this 180 plus 180. That will be 360 to right hand side. So I have minus 360. So this is equation number 2. So now we have 2 equations and 2 variables. We should be able to solve them, which is the 4th step of this analysis, which is to solve the resulting equation. Okay, and I think I will use calculator to solve this linear equation because that is the fastest way, right? So let's set this up here as our solver, and equation solver is number 5. Two variables is number 1, and now we will have to plug in all the coefficients. So I'll have 17, and then minus 10, and then 1350. Okay, and then we will have 4, then minus 5, and then minus 360. And we will have our PA here, which is 230. So we'll have PA is 230 volt. And then what is PB? PB here is the Y value, which is 256. Okay, but that is not the question asked. It is asking about I/O. So we need to do the last step of this question, which is to answer the question. Okay, the question is asking us about I/O, and we can actually calculate I/O because we know VA and we know VB, right? So we know that I/O is VA, where the current comes from, and then minus VB, where the current goes to, and then divided by the resistance between them, that is 1. So we will have PA here is 230 minus this one here is 256, and then divided by 1. So I have I/O here, 230 minus 256, that will be minus 26 divided by 1. But dividing by 1 is not gonna change the numerator. It is an identity element, so we will have minus 26. And the unit here will be in ampere. Okay, so finally we have reached our goal here. This is I/O. I/O is minus 26 ampere. And that is our final answer for this problem. Hopefully I did not make any mistakes in my calculation. Thank you for watching. See you in the next video. Bye bye.